this is logic coding. Today let's look at another backtracking problem called world pattern 2. So we are given two strings. One is a pattern, another is the string, and we want to return true if the string matches the pattern. How do we define match? So if there is some bijective mapping of single character to string such that each character in the pattern is replaced by the string maps to, then the resulting string is S. And the bijective mapping means that no two character maps to the same string and no character maps to two different strings. So if we have A, B, and we have red, blue, and red, blue, obviously we can find the match with A is mapping to red and B is mapping to blue. Same thing with 4 A's. So we divide by 4, A map to ASD, and AB. So for this one, we actually have two different mappings. For each character, where at A, this A can either be mapped to A, or it can be mapped to ASD. Okay, cool. So as long as we can find this pattern, we will just return true. So since we're not sure how many characters in S we should match a specific character, we should explore all the possibilities. If we find a possibility that holds true, then we just return true. Otherwise, we backtrack and explore other opportunities. So the algorithm we will use is to use recursion and backtrack. So for each option, so at pattern I, before that, let's keep two global variable, a p map with char to string, and we also want a s map, just to keep record. So for each pattern at I, let's assume I have another index for string. Starting from J. So J, ideally, we should try the mapping to J, J to J plus 1. And up to the end. So for each pair, we should try to see whether this makes sense or not. If it does, then no problem, but we just do DFS for each pair. So now let's claim these two global variable S map and P map, and we want to return this DFS with pattern, which is fixed, and S pattern with I with 0 actually, and S with 0 as well. Okay, cool. Now let's define this DFS. So naturally I should pass this maybe by reference to save time and space. And S, I would have int J. If we're rich at the end, end condition, if both are at the end, I'll just return true. Otherwise, if either one of them are at the end, just return false. And other than that, we need to consider the constraints and explore. First, let's take our current character at index I. Now we want to explore to which strings that this C can be mapped to. So K naturally starts from J, but it's going to be smaller than this, K++. And this string is going to be equal to S dot substring. So starting index would be K. The length of the starting index would be J, and the length would be K minus J plus 1. Okay, cool. So if either C and are already mapped, so we do, if my P map already has this character and it does not equals to my string, then I return false. And on the other hand, if my smap.count and smap string is not equal to character, I also return false. If you're not so if they're not mapped, I map them, right? I just add the condition into character as well. And yeah, so after this, I just need to do DFS. Okay, if DFS, the next stage would be the same thing pattern, but then I plus 1 S, but then the K would be actually I shouldn't return false, I should just do continue, because I wouldn't be considering this K. And K plus 1, I just return true, and I need to do backtrack as well. So if insert equal to true, I need to erase it. I need to erase this C and string. Till the end, just return false if it doesn't hold. Yeah, I think that's pretty much it. We have two string, we need two index to indicate the DFS, and we do our backtracking. Here, let's try run the code. String. Cool. I think that's pretty much it. Let's try submit. Great, that's it for today.